Welcome to Data Inception. Let's take a deep dive into the databases and their importance. Today's agenda includes the introduction to a database, advantages of using a database, different types of databases, and administration and maintenance of a database. Before we learn about the database, let us understand what is data. In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. A picture, image can also be considered as a data. So what is a database? A database is a systematic collection of data. They support electronic storage and manipulation of data. Databases make data management easy. For example, Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisements, and a lot more. We can provide a countless number of examples for the usage of databases. There are a variety of databases. Some of the most common types of databases include relational database and non-relational database. Relational database is more flexible and easier to manage. These are databases that store data in tables with a defined relationship between them, whereas non-relational databases do not store data in tables with a defined relationship. Instead, they use data models such as documents or graphs. These type of databases is highly performant for large sets of data and are better at scaling to meet the demands. The main goal of using the database is to make it easy to store, manage, and access data. Databases help ensure that data is accurate, consistent, and reliable, which is essential for making informed decisions. The primary job of a database is to ensure the data is available, protected from loss and corruption, and easily accessible as needed. Let's see a few of the advantages of using a database. Databases offer a variety of techniques to store and retrieve data. It serves as an efficient handler to balance the needs of multiple applications using the same data. It has uniform administration procedures for using the data. A database system uses various powerful functions to store and retrieve data efficiently and offers data integrity and security. The databases imply integrity constraint to get a high level of protection against prohibited access to data. It schedules concurrent access to the data in such a manner that only one user can access the data at the time. It also has the reduced application development time. Some of the key advantages of using the databases include categorizing the data for improved data quality, better data organization and management, and for faster data retrieval purposes. Databases can easily categorize and store data in relational databases that can be queried and filtered to extract information for reports. For example, complex queries are easy for users to carry out with SQL, the main query language used with relational database. Databases offer features such as user authentication, data encryption, and data backup and recovery for enhanced security and data integrity purposes. Also, databases can be accessed by multiple users simultaneously for improved collaboration and data sharing. Databases help reduce data redundancy by allowing data to be stored in a centralized location. This means that data only needs to be stored once, which helps reduce the amount of storage space required and ensures that data is consistent across the organization. Relational databases are one of the most common type of databases that are widely used for a variety of applications. This database is fault tolerant and data is eventually consistent. A relational database stores data in tables, with each table consisting of rows and columns. One of the key features of using relational database is its ability to define relationship between the tables. For example, a customer table may be related to another order table, with each order being associated with a specific customers. These types of relationship are defined using keys, which are used to link the data between tables. The main benefit of using relational database model is that it provides an intuitive way to represent data and allows easy access to related data points. As a result, relational databases are most commonly used by organizations that need to manage large amounts of structured data, from tracking inventory to processing transactional data to application logging. There are certain advantages of using relational databases over other traditional databases. Some of them are the flexibility, ACID compliance and ease of use, collaboration, built-in security, database normalization, etc. It's easy to add, update, or delete tables, relationships, and make other changes to data whenever you need without changing the overall database structure or impacting existing applications. Relational databases support ACID durability, that is, atomicity, consistency, isolation, and durability, to ensure data validity regardless of errors, failures, or other potential mishaps. It's easy to run complex queries using SQL, which enables even non-technical users to learn how to interact with the database. Multiple people can cooperate and access data simultaneously. Built-in locking prevents simultaneous access to data when it's being updated. Role-based security ensures data access is limited to specific users. A relational database management system is a program used to create, update, and manage relational databases. Some of the most well-known RDMS include MySQL, PostgreSQL, MariaDB, Microsoft SQL Server, and Oracle Database. Cloud-based relational databases like Cloud SQL, Cloud Spanner, and AllyDB have become increasingly popular as they offer managed services for database maintenance, patching, capacity management, provisioning, and infrastructure support. NoSQL databases or the non-relational databases are databases that store data in a format other than relational tables. NoSQL database emerged in late 2000s as the cost of storage dramatically decreased. Gone were the days of needing to create a complex, difficult to manage data model in order to avoid data duplications. NoSQL databases optimized for developer productivity. As storage costs rapidly decreased, the amount of data that applications needed to store and query increased. This data came in all shapes and sizes, structured, semi-structured, and polymorphic, and defining the schema in advance became nearly impossible. NoSQL databases allow developers to store huge amounts of unstructured data, giving them a lot of flexibility. The unprecedented speed and scale of digital interaction and data consumption seen in the last 2 decades has required businesses to adapt to more modern, fluid approach to how they store data and how they access it. With users worldwide demanding an uninterrupted stream of contents and functions, it's no wonder that databases have had to adapt quickly. The main advantages of using the NoSQL databases are flexibility and scalability. With SQL databases, data is stored in a much more rigid, predefined structure, but with NoSQL, data can be stored in a more free-form fashion without those rigid schemas. NoSQL databases can easily handle any data format, such as structured, semi-structured, and non-structured data in a single data store. Instead of scaling up by adding more servers, NoSQL databases can scale out by using commodity hardware. This has the ability to support increased traffic in order to meet the demand with zero downtime. By scaling out, NoSQL databases can become large and more powerful, which is why they have become the preferred option for evolving datasets. The scale-out architecture of NoSQL database can be particularly valuable when data volume or traffic increases. NoSQL databases can also ingest data and deliver it quickly and reliable, which is why NoSQL databases are used in applications that collect terabytes of data every day. NoSQL databases automatically replicate data across multiple servers, data centers, or cloud resources. In turn, this minimizes the latencies for users no matter where they are located. This feature also works to reduce the burden of database management, which frees up time to focus on other priorities. NoSQL databases are designed for distributed data stores that have extremely large data storage needs. This is what makes NoSQL the ideal choice for big data, real-time web apps, customer 360 online shopping, online gaming, etc. When it comes to database administration and maintenance, it involves a range of tasks, including monitoring the database for performance issues, backing up data, and optimizing the database to ensure optimal performance. A database administrator is responsible for database administration and system maintenance. His primary job is to ensure that data is available, protected from loss and corruption, and easily accessible as needed. Here are some of the key tasks involved in database administration and maintenance. Those include database monitoring, backup and recovery, performance tuning, security management, database upgrades, and migrations. Let's see how a database system administrator performs the key tasks involved in maintaining the database. The system administrator sets up the hardware and deploys the operating system for database server, and then the administrator installs the database software and configures it for the use. As updates and patches are required, the administrator handles this ongoing maintenance. Known as ETL, data extraction, transformation, and loading, refers to efficiently importing large volumes of datasets that have been extracted from multiple systems into a hardware into a data warehouse environment. This external data is cleaned up and transformed to fit the desired format so that it can be imported into central repository. Database backup and recovery is essential because regular backups of databases are ensures that data can be restored in the event of disaster or system failure. In case of a failure, a server failure, or other forms of data loss, the DBA will use existing backups to restore lost information to the system. Different types of failures may require different recovery strategies, and the DBA must be prepared for any eventuality. With technology change, it has become more typical for a database administrator to back up databases to the cloud. A database administrator needs to provide the security based on the company's software and the company's overall system and to minimize the risks. No system is 100% immune to attacks, but implementing best practices can minimize risks. Performance monitoring shows where the database should be tweaked to operate as efficiently as possible. The physical configuration, the way the database is indexed, and how queries are handled can have a dramatic effect on database performance and database tuning. DBAs are on call for troubleshooting in case of any problems. Database administrators are responsible for ensuring that database is secure and that access to the database is restricted to authorized users. Upgrading and migrating a database to a new version or platform can be a complex task, but database administrators should plan and execute and upgrade the migration carefully, ensuring that all data is migrated correctly, and that any potential issues are identified and addressed. On a concluding note, databases can help you manage your business's growing amount of critical data centrally, precisely, and securely. Centralizing information also structures data and prevents duplication, which saves space and allows you to work better and faster, ultimately increasing your overall productivity. A database management system provides organizations a complete, clear view into the way the data is shared. It's ensuring there aren't unnecessary copies of data. Not to mention, a database management system allows organizations to ensure data security and privacy policies to reduce the risk of data breach. The primary goal of database management system is to provide an environment that is both convenient and efficient for users to retrieve and store information. In summary, databases are an essential tool for managing data in today's digital world. Whether it is a relational or non-relational database, effective administration and maintenance is crucial for ensuring that a database runs smoothly and meets the needs of its users. Thank you.